Okay, you should all know IVT. Good morning. Does that make you happier? Good morning, everybody. Good morning, class. I don't. Why do I need to convince them I'm happy? Maybe I'm not happy. It's not a bad morning. It's not a good morning. It's a morning. It's a neutral morning. Look, we've wasted 30 seconds of the video with no content. Let's keep moving on. Alright, so number one, given f of x, this is a polynomial right here. Will there exist a c where c is between 0 and 3, such that f of c equals 4? Justify your answer. You have to do three things. Is f continuous? It's a polynomial. So f of x is continuous. And what's the interval? 0 to 3. Second thing we got to state is what's f of 0 and what's f of 3. So what is f of 0? Very good, class. It's 3. We really should not be talking while I'm teaching. F of 3 is 24? Is it 24? 24. Okay, and then you can easily state this, that so the k value is 4, right? Because I'm looking at 4. So 4 is in between 3 and 24. We agree? Okay. So because of that, the last statement is true. Then you just say at least one c value is in 0 to 3, so that f of c equals 4. How it was the first time around we did it, yeah.
We have to mention like IVT at all.
You do not, believe it or not. It is not required for you to mention IVT. This says that you know IVT. It's a good question, though. Let's go to EVT. We didn't talk about this one, but yet we have talked about it. It just talks about, is there an absolute min, is there an absolute max? Okay, so we've done finding absolute mins, absolute maxes. All it says is, if it's continuous on the interval, then there is a max, there is a min, which makes sense anyway. So if it's continuous, then you're good to go. So for number 2, right here, given this function right here, will it have a minimum on the interval? Will it have a maximum on the interval? So given this function right here, is it continuous? It's a polynomial, people. So since f of x is continuous on -1 and 2, believe it or not, you don't even need that -1 and 2 because a polynomial is continuous everywhere. The only time you need that interval is like if something is not continuous everywhere. And I'll get to an example in a little bit here. So since f of x is continuous, there is a min and max value. That's all you need to say. Again, you do not need to say EVT. Don't need to. It's just given. So here's an example of when you do need to state the interval. Like, let's play pretend, and let's say that I have f of x equals 1 over x on the interval from like 1 to 3. You need to state that it's on this interval because it's 1 over x continuous. It's not a continuous function, so you have to state that it is continuous on 1 to 3. Since this is continuous everywhere, you do not need the interval. But let's put the interval to be safe. So let's just look at these 3 examples now. So does EVT apply for this first one? Yes. Does it have a minimum and max? So this works. What about this one? Tricky one. Does it have intervals closed, right? Does it have endpoints? Does not have endpoint, so it does not work. What about this last guy right here? And what's the reason? Not continuous. It's not continuous. Alright, in terms of EVT questions, it's very rare that they'll ask you if it is. They'll usually just ask you what is the max, what is the min. That's about it. That's what they'll do. I guess it is possible they might have a question like what is the max, what is the min, and they might have a choice that says does not apply. And the only reason it does not apply is because the function is not continuous on the interval. Alright, here is the meat and bones of today, the mean value theorem, MVT. So, MVT states that if a function is continuous on the closed interval and differentiable on the open interval, then there exists a number C such that the derivative is equal to the average rate of change, pretty much. Okay? So that's all it's saying. This is pretty much IVT for derivatives. Okay? If it's continuous and differentiable, then you're good to go. That pretty much states everything. And then this is like the other statement for IVT, is that f prime. This is like the big ol' huge point that we really care about. Okay? So what does that mean? Find out. So on this graph right here, see these endpoints? This is the average rate of change between these two endpoints. Do you agree? That this right here is your f of b minus f of a all over b minus a. That's what this line right there represents. That means that this tangent line appears somewhere on this curve between here and here. And that is true. Where's the tangent line about? Like here-ish? And this is your f prime of whatever our C value is. So those slopes are equal. They're parallel. Okay? It's the same thing here. I don't need to draw it twice. So that's all it's saying, is that that slope from the endpoints will appear somewhere in that graph. So to determine whether the mean value of the theorem can be applied. Okay? Applied just means it needs to be continuous and differentiable. You got those things, boom, you're good to go. On the closed interval, -2 to 2. If it does apply, find all C values on the open interval, -2 to 2. Alright, let's go for it. So does this apply? First thing is it continuous? I can't spell continuous. It's continuous on -2 to 2. Is it differentiable? Again, this is a polynomial. Yes, so f of x is differentiable on the open interval. There is a reason why it has to be open versus closed. Now, it could be closed. I mean, if it's closed, you're still good to go. This is the square root of x, right? It's continuous from 0 to infinity. It's not differentiable at 0. Because differentiable means that the limit from the left and from the right are equal. Is there a limit from the left here? By definition, there's no limit to the left, so it is not differentiable at 0. There is not a tangent line you can draw at 0. Because it's like a corner cusp type of situation. So that's why it has to be on the open interval.
What if you were to do like the points, or it would be the open interval 0 to 1?
Yeah, then you're good. If you can do MVT of this from 0 to 2, for instance, because it is continuous from 0 to 2 in the closed interval, and then it's differentiable from open interval 0 to 2. So that's just an example. Alright, so I'm ready to do the third one. Can we stop talking, please? I'm going to wait for everyone to be done talking. I can hear your whispers. It's not time to whisper. Okay, so what I need to do now is I need to find the derivative of this. So what is the derivative of this? So f prime of x is equal to 4x cubed minus 4x. Okay. And then I need to set this equal to f of 2 minus f of negative 2 all over 2 minus 2. And that's all I'm doing is this right up here. I took the derivative, setting it equal to the average rate of change. Well, what is f of 2? I'll just say it's 0. You agree with me? Is it 0? No, it's 8. I'm lying. It's 8. So it's going to be 8 minus f of negative 2 is going to be the same thing. This is an even function. It's going to be 8 minus 8. That's where I got the 0 from. All over, it should be a negative 2 right there. So it should be 2 minus negative 2, which is 4, which is equal to 0. So 4x cubed minus 4x equals 0. Let's solve for x. How can I solve for x there? There's a GCF and we can factor it from there. What's the GCF? So 4x, what's left on the inside? X minus 1? Squared? So I can factor this to be 4x, x plus 1, x minus 1. So we get x values of 0 and plus and minus 1. Okay, so are all of these in my interval? Okay, this is something you have to graduate to be a C value. You can only graduate to be a C value if you're in the interval. Are these in the interval? Sometimes you gotta cut one of them out, and it's okay. But in this case, all of these are graduating to C values. So you need to find the values of C. This is not a final answer. The final answer is going to be right here. C equals 0 plus and minus 1. Have to be in that interval. What does this mean? What the heck did I just do? I'm going to draw this for you real quick. Just trying to figure out how it's drawn from negative 2 to 2. I'm going to cross there, and I'm going to cross 2. So it looks like it's something like this. Something like that? I don't know. So essentially, from my endpoints, from here to here, we said that that slope was equal to 0. I drew this wrong. I'm just letting you know. I drew it wrong. So this slope, this tangent line is equal to 0. So it's going to also equal 0 at different points. If I drew it right, then whatever. The whole idea is, does the slope equal 0 between negative 2 to 2 at some point? Yeah, it does. It happens 3 times. That's how I'm going to draw it wrong. Happens at 0 and plus and minus 1. I'm sure the graph looks like this. I'm sure that's what the graph looks like. Because you're going to get a 0, 1, 2, 3 times. Alright. Number 4 is the exact same problem. Do you want to just try that one on your own? By exact same problem, I mean like it's a polynomial, endpoints. Try it on your own. See what I do. Thanks so much.
Is this person here too?
Yeah.
Alright. Have a nice day.
Yep. Has anybody ever been in trouble at the counseling office? How could you? That's a great open-ended question right there. How could you go to the counseling office and be in trouble? Neelish, what? What? We'll talk about it off camera. It's your call. You can go now or you can go later. Alright, I got the work up here. I'm not done with my problem, by the way. Nobody's graduated yet. I'm not there yet. Showing all the work. So did you get root 13 over 3? Plus and minus at some point? Any questions where I'm at right now? Okay, so are both of these in the interval? No. One of them has to be, by the way. No, which one's not? Well, that's a shame. So you could have done this problem completely wrong, forgot about plus and minus, and got away with it. That's a shame. So C is equal to root 13 over 3, because the other one is not on the interval. I'll just write that down as a note in case anybody's watching the video in silence. Someone just say, who watches these videos? Anybody actually watch these videos that I do? Neelish does. Do you do that while you do too? Do you see that while you're in the counseling office in trouble? Is that what? No, I need to find a good sponsor. What's up? Oh, yep. I got it. Should be a square root of the whole thing. Thank you. Alright. Hey, a lot of this is just like lots of fluff. So I'm going to kind of move on to where we would apply this stuff. So there's two questions that are very similar to free response questions. I'm going to go over both of those with you. So just flip it. So we're going to skip that next page completely. Those will be on keyed notes if you really care about it. Let's go through this one right here. Okay, so you have a table. The functions f and g are differentiable for all real numbers, and g is strictly increasing. The table above gives values of functions in their first derivatives. Also, h is known as this right here. Explain why there must be an r value between 1 and 3 such that h of r is equal to -5. Which of the three theorems that we learned today, well, we really only learned two of them, and we relearned one. Which of the three theorems that we applied today does this apply to? Explain why there must be a value of r where r is between 1 and 3 such that h of r is equal to -5. It's IVT. Okay? Why is this IVT? There's no derivative. So how do I do IVT? Well, I first state that h is continuous. I can do it on the interval, doesn't matter. It says it's going to be, since these are continuous functions, f and g, any type of composition of continuous functions are continuous, unless you're dividing. We're not dividing, so we're good to go. So h is continuous. What's the second thing I have to do? Find h of 1. Okay, so what is h of 1? Isn't it the same thing as f of g of 1? And then minus 6. What is g of 1? 2. So what's f of 2? 9. What's 9 minus 6? 3. Let's find h of 3. That's f of g of 3. Minus 6. Well, what is g of 3? 4. What is f of 4? Negative 1. So I have negative 1 minus 6, which is negative 7, you all said? That's great. So what's my k value in this one? It's negative 5. So negative 5 is in between those, correct? So then, what's the conclusion say? There exists. That's why I write the same thing I wrote last time. There is at least one. I don't want to say C value because it gave me R. So there's at least one R value. In 1 to 3. So that h of r equals negative 5. Alright, we good? Alright, next one, B. Explain why there must be a C value for between 1 and 3 such that h prime of C is equal to negative 5. Which one is this one? How is this one MVT? It's the derivatives. What's the difference between IVT and MVT? Knowing which one to do. Regular versus the derivative. MVT is the derivative. So how do I do MVT now? So h is continuous. Do I need to mention the interval in this one? The answer is no. Why? Very good, because f and g are differentiable all the way through. You can mention the interval, you don't have to. Do you want me to? Okay. So h is continuous, h is differentiable, so what do you need to do now? I need to find h prime. Because closed interval, open interval. And I know it says, doesn't have it right here, but since it says it's differentiable all the way through, I know it's differentiable closed 1, closed 3. Okay, so what's h prime equal, first off? What's h prime of x? Oh, look, it's those problems that you hate. Oh. Hey, look, they pop up again. This is chain rule. So what's the derivative of the inside? G prime of x. What's the derivative of the outside? F prime. Inside stays the same. And then minus, what's the derivative of 6? Nothing. So do I need the minus 6? No. Okay, so I'm good. So now let's go ahead and find, and this should equal h of 3 minus h of 1 all over 3 minus 1. What is h of 3? We have it already up here, correct? So it's negative 7 minus 3 all over 2, which is negative 5. Alright, there's actually nothing else to do. Ain't I done right now? Didn't I just prove that H prime, which is all that junk, which I now know I didn't really need to do, isn't H prime equal to 5? Negative 5? Didn't I just figure that out? Okay. So this work isn't necessary. That's kind of nice. Good practice, though. So that's it. You don't need anything else. Done. Questions on that one? This one asks to find a C-value. No. What would you have to do if you had to find a C-value? Set this equal to that, which is like something you can't do because you don't have enough information anyway. So that's good. Here's another free response. I'll kind of just run through it real quick. Alright, so we have a temperature of water in a tub at time t is modeled by strictly increasing twice differentiable function, where WT is measured in degrees Fahrenheit and T is measured in minutes. At T0, temperature is 55, the water is heated for 30 minutes, beginning at time t equals 0, values of WT, that's like times, blah, 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 all in the table. Okay, estimate W prime at 12. Who remembers how to do that? Don't you just, it's between 9 and 15 to find the average rate of change. So W prime of 12 is approximately W 15 minus W of 9 all over 15 minus 9. Which is, I have the answers in front of me. So if we had a calculator in front of us, we would say it would be 6.1 over 6. And then what would the units be? Degrees Fahrenheit per minute. Isn't the top degrees Fahrenheit? Isn't the bottom per minute? So that's degrees Fahrenheit per minute. Part B, explain why there must be a time between 4 and 15 such that the temperature has to be 65 degrees. Which one is that? Which rule is that one? IVT. So let's go ahead and do it. So IVT, W of T is continuous. How do I know that? Because it's a differentiable function. It's actually twice differentiable. If it's differentiable, it has to be continuous. So it's continuous on 4 to 15. W15 is equal to what? Very good, 67.9. Just reading the table. W of 4 is equal to 57.1. So 57.1 is less than 65, which is less than 67.9. Where did I get all those numbers from? The table. Where did I get this number from, 65? The question. So there is a T value, so there's a time essentially where WT equals 65. Alright, and then C, explain why there must be a time such that W prime of T is equal to that. This is going to be MVT. So MVT, we say that W is continuous on the interval. Is that interval absolutely necessary at the moment? It actually is not. Why are these intervals not necessary for this specific problem? Why are these intervals not necessary for this specific problem? Because it's differential all the way through. It's stated at the beginning. And then 3 is w prime of t. There's no derivative to take here of anything. Is equal to w of 4 minus w of 0 all over 4 minus 0. What is w of 4? It's on the table. 57.1 minus 55.0 all over 4, which equals 0.525. And that's it. Again, if I don't need to find the time t, there's not a lot of work. If I need to find the time t, I got a little bit of work to do. Alright. Any questions on IVT, MVT? Did we even do anything with EVT, really? No, because it's really not that important. The only thing you need to know of EVT is how to find absolute minimums and maximums, which we have done already. Okay, so just give you a heads up. So like I said, we have a test next week on Friday. This is half of it. Right there. That's good. Yeah, that's good. MVT, IVT, EVT. That's half of it right there. Neelish knows. He's like, I'm ready for this to be the most difficult thing I've seen in my entire life. It will be calculator active. Yeah, because MVT you can use your calculator for some of this stuff. So just be aware. It'll be calculator active. So you can use a calculator. So just be aware of how to use your calculator, such as subtracting numbers, dividing numbers. It'll be good to go.